Okay, today we're going to be talking about how to actually create a scatter plot properly. There's some really important fundamentals that you need to be able to do consistently in order to do this skill correctly. So we do have a little bit of vocabulary, but I'm going to introduce it as we create our scatter plot. So what I've got for you today is a blank grid and a series of data. So we're going to take that data and we're going to put that onto this graph, and we're going to do that properly. So the first thing we need to do is we need to put in our axes. Now you remember from Unit 2 that the axes are our X and Y, and that's our vertical and horizontal. So I'm going to put in my Y-axis and my X-axis. That's not as straight as I would like it. I'm actually going to do that one more time. Okay, that's pretty good. So now I have my Y and my X axis. Now it does only need to be in one quadrant because all of my data is positive. I don't have any negative numbers. I don't have to worry about having a negative side to this graph. In some scatter plots you will have negative numbers, and then you have to adjust your axes accordingly. In this one, everything's positive, so we can go with that. Now the next part that we're going to do is we're going to label the axis. So what are we going to put on each axis? And a label has two parts. It has the title, the actual label of it, and it has units so that we know exactly what each point is going to represent. So on the y-axis, it says homework mark. So I'm going to write that here. Homework mark. And if we look at that, we have a bunch of different data. It looks like the highest mark on there is 50. So we can say that that was out of 50. Okay, so you see it says homework mark out of 50. That means we know what that was out of. Test mark is going to be down here. This is my label for my X. And that is going to be a percentage out of 100. So we can, the units there are percent. That's what it's going to give us. So we have units discussed and labels discussed. What about a title? We need a title for a graph. It's going to tell us what the scatter plot is about. So what's a good title for this one? So the relationship between homework marks and test marks. The relationship between homework marks and test marks. That's going to be my title. I want to find out if there's a relationship between how well you do on your homework and how well you do in your test. If you do really well on your homework, does that mean you're more likely to do really well on your test? So let's start graphing. We've got the title done. Can we graph right now? No. We have one more thing that we need. We need to have a scale. We need to know what the values are. And the most important thing with a scale, I'm going to highlight this for you. Okay. Must be evenly distributed. Must be evenly distributed. So, watch what I mean. I'm going to switch to a different color here just so you can see. The homework mark goes up to 50. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spots that I can use. And if I go by fives, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, that will work. You want to try and use as much space as possible. So I'm going to go 5, 10, 15, 20, 30, 35, 40, 45, 50. Okay, so now you can see I've spread that up. We'll just take that to the top, even though we don't really need to. Now the test mark is going to go to 100. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. I would need 20 if I was going to go by 5s. So I can't go by 5s. So I might be able to go by 7s or 8s if you wanted to. In this case, I think I will go by 10s, just to make it easier. So we know that this is 0. So we've got 10, 20, 30, 40, 50, 70, 80, 90, 100. It's too bad that we didn't have 20 spots on there. So there we go. I've got a scale. You could do your scale by 8s, you could do it by 7s, and that's still fine as long as it goes evenly. I can't go 10, 15, 25, 31, 62, because what you're going to end up doing is forcing all of your data into a straight line. And you don't want to force it into a straight line because the way the line looks has meaning. Whether it's linear or nonlinear, it tells us something about the relationship. So if you force it into a straight line, you're destroying all the information about the relationship, which is the whole point. So let's graph. I'm going to change colors again to put my points on here just so that you can see them. So my first one is x61, y35. So x61, y35 is right there. My next one is 95, 50. 95, where's 95? 50 is right there. Should be right on that line. Then 44, 5. 44, 5. 93, 50. There's another spot right there. 63, 15. 80, 34. 62, 16. 62, 16 is there. 95, 50. 95, 50. Oh, that's another one right on that spot. 65 and 7. 65 and 7. 88 and 38. 88 and 38. There. So now I've graphed all of the data. You can see I have a scatter plot. It has a title. It has axes. It has labels on the axes. It has units on the labels. And it has a scale that goes evenly. So now what could we say about this relationship? Is there a relationship between homework and test marks? And the answer is yes. It looks like a positive relationship between, and we have to do our X first, so between test marks and homework marks. And how would we state that in a conclusion sentence or a hypothesis sentence? I'd say as, now remember this is going to be as the independent variable increases. And the independent variable is always on the X. So as test marks increase, homework marks also increase. Okay, now remember, test marks is our independent variable, and homework marks is our dependent variable. So when you're doing a hypothesis statement or a concluding sentence, you always structure them the same way. As the independent variable changes, what happens to the dependent variable? For a hypothesis, it's what do you think happens to the independent variable? And for a conclusion sentence, it's what have you discovered happens to the independent variable?